Welcome dear students, welcome back to our today's online class. In our today's class we are going to discuss about some important chemical reactions and properties of sulfuric acid. Sulfuric acid, which has formula H2SO4, it is a diabasic acid because when it is dissolved in water, one molecule of sulfuric acid produces 2 hydronium ion. Therefore, sulfuric acid is a diabasic acid having relative molecular mass 98. So let us start our today's class. Now, before starting our today's class, let us see some facts about sulfuric acid. Sulfuric acid is a colorless, tasteless, and highly corrosive diabasic acid. It is colorless and it is tasteless. The density of pure sulfuric acid is 1.85 grams per cc, which means it is heavier or denser than water. It is also known as oil of vitriol because in the Middle Ages it was obtained as oily viscous liquid by heating crystals of green vitriol, which is nothing but hydrated iron sulfate. So when hydrated iron sulfate was heated, then green viscous liquid was obtained, which was actually sulfuric acid. Therefore they called sulfuric acid as oil of vitriol at the time. It is also called king of chemicals because this chemical is very widely used in most of the reactions and to prepare other different chemicals. No other compound manufactured has larger number of use than sulfuric acid. Hence it is called king of chemicals also. It is widely used reagent and it is used in the preparation of halogens, hydrogen, carbon dioxide, and many more other gases. It is used in the preparation of fertilizers, dyes, drugs, explosives, and even other volatile mineral acids. It is used also as a dehydrating agent as well as drying agent and also as an oxidizing agent. About dehydrating agent and drying agent we have already learned in our class 9 syllabus. Both removes water, but dehydrating agent has some difference between a drying agent, which we have already discussed. Now, before going to detail, we will see our reduced syllabus first about sulfuric acid. So this year you only need to study 4 main properties of sulfuric acid. You don't need to study about preparation of sulfuric acid, which is by contact process. You don't need to study about that, but I suggest you please go through it. The first property which we have to see is sulfuric acid as an acid when it is dilute. So its behavior as an acid when dilute. So here we have to study about reaction of sulfuric acid, dilute sulfuric acid with metals, metal oxides, and other different compounds. Second, we have to study about why concentrated sulfuric acid acts as an oxidizing agent, taking examples of carbon and sulfur. Third, we have to learn about dehydrating property of concentrated sulfuric acid, taking examples of dehydration of sugar and copper 2 sulfate crystals. And finally, we have to study sulfuric acid as a non-volatile acid, taking example of reaction with sodium or potassium chloride and sodium or potassium nitrate. So without wasting time, let us start our today's class according to new reduced syllabus. First, we will study about dilute sulfuric acid as an acid, dilute H2SO4 as an acid. Here we will first discuss about reaction with metals and about the reaction of acids We have already studied in our earlier chapter acid, bases, and salt, the different reactions of acid with different compounds and elements. So the first reaction we'll study here is reaction of dilute sulfuric acid with metals. Dilute sulfuric acid reacts with metals which are above hydrogen in the activity series. So I hope you remember activity series of metals. So those metals which are above hydrogen in the activity series, they all react with dilute sulfuric acid, producing metallic sulfate along with the evolution of hydrogen gas at ordinary temperature. So this gas, hydrogen gas, is one of the very important product formed as a result of reaction of dilute sulfuric acid with metals. Let's see with example. Magnesium reacts with dilute sulfuric acid to produce metal sulfate, which is magnesium sulfate. This is also a salt plus evolution of hydrogen. It reacts with zinc to produce zinc sulfate, a salt plus evolution of hydrogen is there. Iron reacts with sulfuric acid to produce iron sulfate. This is metallic salt, okay, and there is a production of hydrogen gas as well. So all these metals, they are above hydrogen in the activity series, and hence when they react with dilute sulfuric acid, they all produce hydrogen gas. Let's see another reaction of dilute sulfuric acid. Reactions with metal oxides and metal hydroxides. Metal oxides and metal hydroxides are also known as bases. So here we are going to study about reaction of acid, dilute sulfuric acid with base, and that reaction is known as neutralization reaction. Let's see that. It neutralizes metal oxides and hydroxides to form salt and water. The two main products of neutralization reaction are salt and water. In fact, they are the only product, salt and water. Okay, if they produces product other than salt and water, then that reaction will not be called neutralization reaction. You have to remember that. Let's take an example. Copper oxide, copper 2 oxide. This is copper 2 oxide. This is metallic oxide, reacts with dilute sulfuric acid to produce copper sulfate. So this is a salt and water. Iron oxide, iron 2 oxide, reacts with dilute sulfuric acid to produce iron sulfate. This is again a salt along with water. Sodium hydroxide, this is a base alkali, reacts with sulfuric acid to produce sodium bisulfate. So this hydrogen makes it bisulfate, and this is also a salt, but since here we have one replaceable hydrogen, therefore this is an acidic salt. So sodium hydroxide reacts with sulfuric acid to produce sodium bisulfate, an acidic salt plus water. If the concentration of sodium hydroxide is taken in larger quantity, then the same reaction will produce sodium sulfate, a normal salt plus water. Okay, so if the concentration of sodium hydroxide is less, it will produce acidic salt. If the concentration of sodium hydroxide is little more, it will produce normal salt along with water. Let us see the third reaction, a reaction of dilute sulfuric acid with metal carbonates or bicarbonates. Carbonates, CO3, okay, component, bicarbonate, HCO3 component. So reaction of these carbonates and bicarbonates with acid will produce one very important product, that is carbon dioxide along with other products. Let's see. It reacts with metal carbonates or bicarbonates, liberating carbon dioxide gas. So you have to remember this, carbon dioxide gas. So carbonates, carbon dioxide gas. Bicarbonates, carbon dioxide gas. Let's take some example. Sodium carbonate reacts with dilute sulfuric acid to produce sodium sulfate. This is a salt, water, along with the evolution of carbon dioxide gas. In the same way, sodium bicarbonate reacts with dilute sulfuric acid to produce sodium sulfate, water, along with the evolution of carbon dioxide gas. So you have to remember these reactions. Let's see reaction of dilute sulfuric acid with metal sulfides. So sulfides containing sulfur S. Okay. So when dilute acids reacts with sulfides, metal sulfides, one of the main product will be hydrogen sulfide gas. So let's see that. When dilute sulfuric acid reacts with metal sulfide, it evolves hydrogen sulfide. Okay, let's take some example. Sodium sulfide reacts with dilute sulfuric acid to produce sodium sulfate along with the evolution of hydrogen sulfide gas. Okay, to write this type of chemical reaction, it is very easy. Just interchange the ions. Sodium will go to sulfate. These two will combine together, Na2SO4 like this, and this two will combine with each other. So this is exchange of ions with each other. Okay. In the same way, zinc sulfide reacts with dilute sulfuric acid to produce zinc sulfate along with the evolution of hydrogen sulfide gas, which has a pungent smell. Now let's see the fifth reaction of dilute sulfuric acid, that is with sulfites and bisulfites. Sulfites means SO3, sulfates means SO4 component, whereas sulfite means one less oxygen, so it is SO3. Bisulfites means HSO3. So let's see the reaction. It evolves sulfur dioxide gas from metal sulfides and bisulfides. So when dilute sulfuric acid reacts with metal sulfides or bisulfides, which gas is produced as one of the main product? Sulfur dioxide gas. Let's see examples. Sodium sulfite. Why it is sulfite? Because here we have one less oxygen. Instead of SO4, had it been SO4, this would have been sodium sulfate. But here we have SO3 only, so this is sodium sulfite. Reacts with dilute sulfuric acid to produce sodium sulfate. This is exchange of ion plus water along with the evolution of sulfur dioxide gas. In the same way, sodium bisulfite react with dilute sulfuric acid to produce sodium sulfate, water along with the evolution of sulfur dioxide gas. So these are the reactions which proves the acidic nature of dilute sulfuric acid. Now let us see sulfuric acid as an oxidizing agent. The oxidizing property of concentrated sulfuric acid. Here we have to focus on concentrated sulfuric acid. Why? Because dilute sulfuric acid does not act as an oxidizing agent. Dilute sulfuric acid is not an oxidizing agent. Only concentrated sulfuric acid is an oxidizing agent. Why? Because this concentrated sulfuric acid on thermal decomposition, when it is heated, it yields nascent oxygen, that is atomic form of oxygen. And this nascent oxygen is very active, and therefore it combines with other element or compounds and hence oxidizes those particular elements or compounds. So the oxidizing property of sulfuric acid, concentrated sulfuric acid, is due to the production of nascent oxygen on thermal decomposition. Let's see some examples. Let's see how it produces nascent oxygen first. The sulfuric acid on thermal decomposition produces water, sulfur dioxide as well as nascent oxygen, and it is this nascent oxygen which is responsible for the oxidizing nature of concentrated sulfuric acid. Oxidation of carbon and sulfur. Let's see these two examples. So when concentrated sulfuric acid is added to carbon dioxide gas and sulfur dioxide gas gets produced. They evolve along with the production of water. So here carbon has been oxidized to carbon dioxide. So this is an example of oxidation reaction. In the same way, when concentrated sulfuric acid is added to sulfur, this sulfur gets oxidized to sulfur dioxide gas over here and water, and this acid itself gets reduced to water. So these two examples you have to learn according to reduced syllabus. Let's see now sulfuric acid as a dehydrating agent. So sulfuric acid as a dehydrating agent. Sulfuric acid has a great affinity for water and it removes elements of water. So what are the elements of water? Water is made up of hydrogen and oxygen. So it removes elements of water from other compounds in the form of water. So if the compound does not have any water molecules attached to it, but if that compound has hydrogen and oxygen in it, then this sulfuric acid will remove those hydrogen and oxygen atoms from the compound in the form of water. It combines hydrogen and oxygen to form water, and that water will be removed. And this property is known as dehydrating property, and hence sulfuric acid acts as a very, very good dehydrating agent. Let's see example of dehydration of sugar. Now we all know sugar does not have water molecule in it, but we definitely know that sugar is made up of carbon, hydrogen and oxygen, and this hydrogen and oxygen is present in sugar. Let's see that example. The molecular formula of sugar is C12H22O11. So here we already have hydrogen and oxygen. So this hydrogen and oxygen are necessary to produce water. So when concentrated sulfuric acid is added to sugar, the sugar crystals are white in color. When concentrated sulfuric acid is added to sugar crystal, this sugar crystal will now break down, because this sulfuric acid will remove hydrogen and oxygen from sugar. It combines hydrogen and oxygen to form water. So water has been removed. Although there is no water initially, water gets removed from the sugar molecule and carbon is left alone in the form of solid. So here, from the compound which does not have water but has elements of water, then concentrated sulfuric acid will remove those elements of water, combine them and remove it in the form of water, leaving the remaining component of the compound. How we can say that? Because in the beginning of this reaction, sugar crystals has white appearance, and after the completion of reaction, this sugar molecule converts into black carbon solid along with water. So this is the example of dehydrating agent of sulfuric acid taking sugar crystals. We can also do the same experiment with another compound, that is dehydration of blue copper sulfate. It is also called blue vitriol. So by the name only, we can say that this copper sulfate solution is blue in color. So let's see what happens when the dehydrating effect takes place. Now copper sulfate, this blue copper sulfate is copper sulfate with 5 molecules of water, pentahydrate. This is pentahydrate. So when copper sulfate, this is blue in color, is to this solution, if we add concentrated sulfuric acid, excuse me, then this copper sulfate, from this molecule, this water gets removed and gets separated like this, 5 molecules of water. And what is left behind? Copper sulfate compound as solid. How we can say that copper sulfate has been separated? By looking at their color. Initially, pentahydrate copper sulfate looks blue in color. After the completion of reaction, we will get white precipitate of copper sulfate, which proves that the water molecule has been removed, because this water molecule, which is also called water of crystallization, gives blue color to copper sulfate. So once all the water molecules gets removed, the blue color property also gets removed, and instead of blue, the real white color of copper sulfate solid appears as white. Okay, so this is the dehydrating effect of sulfuric acid on sugar and blue copper to sulfate. Now let's see the non-volatile nature of sulfuric acid. Non-volatile means it does not convert into its vapor form very easily. Why? Because the boiling point of concentrated sulfuric acid is high. It is about 338 degrees Celsius, which is very high compared to the boiling point of water. It is more than 3 times. Due to this high temperature boiling point, the sulfuric acid remains non-volatile at ordinary temperature. And this non-volatile nature of sulfuric acid is used to prepare other volatile acids like hydrochloric acid or nitric acids. Let's see that examples. How we can prepare hydrochloric acid? We have already learned in our earlier chapter also. So we can react sodium chloride, a salt, with sulfuric acid. Now this is non-volatile, okay, so it will react with sodium chloride to form sodium bisulfate. This is SO4. I'm sorry, this is NaHSO4. This is in subscript. Plus hydrochloric acid is formed. In the same way, when sodium nitrate is treated with sulfuric acid, non-volatile acid, sodium bisulfate, an acidic salt, gets formed along with nitric acid, HNO3. So these reactions, the non-volatile nature of sulfuric acid can be used to prepare other volatile acids. The reason behind that is, if we use here volatile acid to produce another volatile acid, then in the product, since this is also volatile and the product is also volatile, we will not get pure product, this product. The reactant will also vaporize and gets mixed with the product, and it will be difficult to separate reactants from the products. Hence, we use non-volatile because it will not vaporize and get mixed with the product formed. So these are some of the reactions which we have to learn according to new reduced syllabus. Okay, boys, based on today's class, you have your today's assignment number 10. So these are the questions which are very short. Though the question looks very long, but they are short. They are objective type. Either you have to write chemical reactions or your observations. Please complete your today's assignment and send it to me as early as possible, and also complete your pending assignments before we complete our final tabulation for this year. Until we meet next time, stay safe and do all things well.